Hi everyone, my name is Erika. I am 22 years old, studying petrochemical processes in Universidad Autónoma de Tamaulipas. I'm actually about to graduate, and the reason why I'm here making this video is to evaluate my final grades. We have like this kind of little project where we have to make a presentation and then about this topic make this video and upload it on YouTube. Well, my subject title is polyethylene. I'm going to talk a bit about its definition, how is it produced, where is it produced, and some of the applications we can use.
The polymers are defined as macromolecules composed of one or more chemical units, known as monomers, that are repeated throughout a chain. An example, as we can see in the picture, could be polyethylene. The monomer is ethylene, which is repeated a number of times throughout the chain. Depending on the repetition or variety of monomers, polymers are classified as homopolymer and copolymer. The first is formed by the same monomer throughout its chain, and the second one is formed by at least two different monomers along the entire chain. And the formation of the polymer chains are produced by different polyreactions that can occur between monomers. These reactions are classified as polymerization, polycondensation, and polyaddition. Ethylene is the most important organic chemical that exists for the industry, and it is for this reason that it is manufactured by tonnage. It is the basic component of a wide range of chemical products, from plastics to antifreeze solutions and solvents. Ethylene is a small gaseous hydrocarbon that is produced naturally, but that can also be produced or obtained as a result of combustion. Polyethylene is one of the most widely used thermoplastic, and its ever-increasing demand is due to the availability of monomer ethylene from naphtha and gas cracker plant. Some of the other driving forces for fast growth and use of polyethylene are the ease processing of the polymer, its relative cost, resistant to chemicals, and its flexibility. Polyolefin is a family of polymers derived from a particular group of base material known as olefins. Are the world's fastest growing polymer family. Polyolefins such as polyethylene and polypropylene are commodity plastics found in applications varying from household items such as grocery bags, containers, carpets, toys, and appliances, to high-tech products such as engineering plastic, industrial pipes, automotive parts, metal appliances, and even prosthetic implants. Ethylene and propylene are monomers from polyethylene and polypropylene respectively. Global polyolefin market is likely to be 150 million tons by 2015 and 200 million tons by the year of 2020. Low-density polyethylene is a highly branched homopolymer that has ethylene as a monomeric unit. It is obtained from gaseous ethylene, very pure, polymerized in the presence of an initiator. The greatest use of low-density polyethylene is in the packaging sector, such as bags, industrial packaging, laminations, lining film, shrinkable and stretchable film, insulation for cables and conductors, conduit pipes, greenhouse film, irrigation pipes, and irrigation system. High-density polyethylene is a homopolymer with linear structure with few branches that are also very short. Low-pressure processes are used to obtain them, and the catalysts used are those of Ziegler-Natta. The reaction is carried out on the condition of 1 to 100 kilograms per square centimeter of pressure, and the temperature is between 25 to 100 degrees. With this polyethylene, you can produce garbage bags, bottles for milk and yogurt, containers for chemical products, gardening, detergents and cleaners, jars, envelope, cable insulation and wire, gasoline containers, and others. In the following chart, we can appreciate 4 different processes and their licensors, starting with British Petroleum Chemicals with Innovent process, which consists in polymerization and fluidized bed reactor using Ziegler-Natta catalyst or chromium catalyst with a temperature of 75 to 110 degrees Celsius, obtaining LDPE and high-density polyethylene. The Brewster process by Borealis Association uses gas phase low pressure reactor, Ziegler-Natta catalyst, comonomer hydrogen, pre-polymerization in slurry loop, reactor in fluidized reactor, and the temperature is the same, obtaining bimodal and unimodal linear low-density polyethylene and medium-density polyethylene. Exxon Chemicals Corporation uses high-pressure free radical process. The polymerization occurs in autoclavable reactors or a tubular reactor, obtaining linear low-density polyethylene. And DuPont use Sclairtech process. Polyethylene is produced by solution of polymerization using ethylene gas and cyclohexane as solvent, comonomer, butane, or octane, or both, and the catalyst is Ziegler-Natta catalyst, obtaining high density, medium density, and linear low density polyethylene. In the following diagram, we can see the comonomer purification, the ethylene purification and compression, the hydrogen purification if applicable, and the catalyst preparation to start the polymerization, where we can find the solvent recover if applicable, and also we can recover the gas. Recycle to the gas compressor, and then we turn to the degassing section when the polymer without and conditional drying. We have the additive, destruction, and the pelletizing, where the storage, silos, bagging, and pelletizing, we can obtain the final product. Now, the applications of the linear low-density polyethylene is for heavy-duty bags, covers, buckets and containers, and stretch films. Now for the high-density polyethylene, we have hard hats, detergent bottles, natural gas and water distribution piping, food storage containers, and bottle caps. With low-density polyethylene, we can obtain plastic bags, dispensing bottles, film warps, cables insulation, and general-purpose containers. Where is it produced? On the following chart, we have polyethylene in Mexico since 1995 to 2012. On grade, we can observe the capacity of production in the plant of Mexico. As we can see, the change between these years hasn't improved. The yellow one is the total production, which remains kind the same. The importation, it's kind of varying since 1995 to the 2000s, and then kind of increased but remained the same. The exportation is being very low on the blue one, as we can observe, and the green one is the consumption, which it did change between 1995 to 2000s, and this means that we need more production of polyethylene here in this country. A little bit of history. Complexes generating polyethylene in Mexico. Escolin Chemical Complex, which produces low-density polyethylene with a capacity of 55 maximum admissible technical mass, which started its operation in 1971. Cangrejera Chemical Complex, which produces low-density polyethylene with a capacity of 350 maximum admissible mass, which started its operation in 1981 to 1986. And Morelos Chemical Complex, which produces high-density polyethylene with a capacity of 100 maximum admissible mass. Its date of beginning operation was in 1989 to 1999. Since April 6, 2016, the IDESA Petrochemical Complex starts polyethylene production operations. The manufacture of polyethylenes increases gradually until reaching the maximum production range, 1,050,000 tons per year. The supply of this product to customers will be available once guaranteed the resin meets the highest level of quality. This Grupo IDESA distributes its product to Baja California, Sinaloa, Jalisco, Coahuila, Nuevo León, Zacatecas, San Luis Potosí, and Hidalgo, between others. This company is 100% Mexican, and it's located in Coatzacoalcos, Veracruz, Mexico.